Good morning, Vietnam. Yesterday we did exercises 120 and 121, and we did some work on the fold program, which is exercise 122, and we didn't get it to work, and I have done some trial and error, or as they call it in Trailer Park Boys, I did some denial and error, and I got a working program off screen, and I'm going to try and kind of reproduce the output on screen. And yep, let me quickly get to here. This directory is empty. I'm going to start by creating a new empty file and start by defining int main. And this time we are for this exercise we're not going to be using getchar. We're going to use getline because it is very convenient to have the knowledge of the whole line. So I'm going to start by allocating a buffer for a line. Not really allocating. I'm going to no, include. What am I doing? Include stdioh and include standard library for free and include string age for null, right? So char line is null, size t, number of red bytes, length, and while number of red bytes equals getline line length, and this has to be a reference, and standard input is not equal to -1. So for each line we could first say okay, so the goal of this program, maybe I will read it again. Write a program to fold long input lines into 2 or more shorter lines after the last non-blank character that occurs before the nth column of input. Make sure your program does something intelligent with very long lines, and if there are no blanks or tabs before the specified column. So the idea is that with some very long, okay, maybe I'll show you on the screen. So cp08 and fold test md to this directory. We copy also the git ignore from that directory, right? And we may also want to copy the make file, because we in this make file I'm specifying compiler flags and specifying that I want to compile with Clang, so we can use LLDB for debugging. And the okay, maybe this file we are going to use for testing, it has pretty long lines. This is the beginning of my blog post, and I usually do not fold lines because there is no need to on modern computers. So the idea is that after the column number 80 or something, we don't want to have any data, any text after line 80. So sometime here after the last space we put a new line, and this is what this program is supposed to do. And in order to do that, we need to define our threshold like this, and yes, so Yeah, so I actually got this this program working with a recursive solution, but most of the time an iterative solution has better performance than a recursive solution. So I asked my friend Claude AI off screen, because we're not doing this on screen, to show me an iterative solution. And I don't really remember what it was, but basically there was a start and an end. And I think start was initialized with 0 and end was initialized with n red minus 1, right? And equals, okay, and equals and the red minus 1, right? Or something like this. And basically you want to if while start is less than end, if end minus start is less than threshold, basically just printf the line, at start and break, and it was something like this, right? Okay, I'll use a variable like I or something. So we're also going to need the position of the last white space, and we initialize last space as -1, which means that there is no space, and then for int I equals start plus threshold, I is greater than start, I minus minus, we try to find the last white space, int C as well. Okay, well, C equals line character I in the string, and then if C equals a space or C equals a tab, then last space equals I break. If last space equals -1, this means that there was no white space found in section break word. Okay. and this means that we yeah, this basically means that we plus space equals -1, we set last space to start plus threshold, right? And then we can print this string, right? So for I equals start they want to include, okay, last space equals threshold plus I. Do we also want to include? No, we don't want to include threshold plus 1, right? I is less than last space, I plus plus, put char line of I, and put char new line, and start equals last space plus 1, and we iterate over and over again, right? So let's see if this compiles, and let's see if this, okay, well, this was easy. So yeah, this seems to work. Let's see if we can also make it work if we have a line with like a very, okay, with a very long word, right? So we have one character, and I'm going to paste it. Okay, well, yeah, this no, this won't work because this is Chinese, right? And it could break if we try to split characters between like we inside a Unicode character. So I'm going to copy this character and paste it 149 times. So we are at column 150. And yep, so and how many are here? Yeah, I can probably just cut the last two lines, right? So tail -2 and head minus head 1. Okay, and count the characters. Okay, so this is one too many. Does it also include the trailing white space? Okay, no. Okay, so this is one too many. Last space equals threshold. Okay, make fold. Now it's 80. Like so. So now this is, it may be hard to see it, but this should now be exactly 80 columns long. And okay, so this is pretty cryptic, so let me go over this this program again, and maybe I will also add some comments. So we iterate over the input by reading a line. Also, we haven't freed the line at the end. Okay. So first we define a variable for a line, and this has to be a char pointer. And the reason it has to be a char pointer is because getline takes a pointer to a pointer of characters, so it may reallocate it, and then the second argument is a pointer to the length, which will be set by getline, and this length represents the size of the buffer that was allocated. And then we read a line from standard input, and on the last line of the input, getline will return -1, which I think is end of file. So wait, do we actually? Yeah, so wait, and how long is this? This should be 70, so I think we may be cutting some output, right? Wait, what? So these lines should be 10. This line should be 10 characters longer than this one, because the last line is 150 characters long. So if this is 11 characters longer, then this means we cut something from the end of this string. So last space equals start plus threshold, and yeah, so we definitely have an off by 1. Last there's the last space. Maybe it's less or no. Should we do it like this? Maybe. Now we are 2 characters longer than we wanted. How long is this? 82. Yeah, this is 81. This is correct, and but we also want the last. And what about the last line? Is 68. It's even worse. So make fold. This is 80. This is exactly what it's supposed to be, right? This is 69, and it should be longer. So why is it we Okay, I think it's because we are starting at last space, right? And okay, yes. So I think the solution is that if there was no white space before the threshold, then we should not omit the first character in the next line, which would be a new line. So if the last space was -1, and well then yeah, maybe we need a new variable. Yeah, something like next start. I don't think this is a smart. This is a very smart solution, but whatever. Next start equals last space +1, and next start equals last space, exactly last space, and then start equals next start. Okay, so this way, with this modification, it seems that the lines are correctly divided, because the second last line is exactly 80 characters long, and the last one is 70 characters long. So maybe like this. So these, yeah, this is 150 characters of text, and this line is exactly 80 characters long, this one is exactly 70 characters long, and for the whole text it also seems that there isn't any line where the text is longer than 80 characters, which also is valid output. And okay, now let me again go over this program to clarify it. So we iterate over each line. Also, we do not really need the end red variable. We could just use end here, and then like so. It still seems to work correctly. Great. So start equals 0. Yeah, okay. So for each line, we read each line in the standard input, and we reset the start variable to 0. This start variable is, we can think of it as a beginning of a string slice. So we start at the beginning of a line, and then we will be going in chunks over the whole line we have read. We find a place where we can break the line, we break the line, and then we retry with a new beginning of a line. So firstly, we iterate until the start of the line is before the end. So for example, if we for some reason decided to add like 80 to the start, then and the line was only 70 characters long, then it would be yeah, actually this could probably also work with while true, while one, okay, or this could be a 4, an empty 4, right? It would still work. So this condition doesn't really matter. We can basically just loop, and or we could say, yeah, this makes sense. So we loop indefinitely, and if the remaining part of a line is shorter than the threshold, or exactly as long as the threshold, then we just print the line and break it, because this will be the last part of the line that we still have to break. And then we search for the last white space character before the threshold, and here we initialize it with -1 first, so that we can say that, so that if there is no white space in this line, we will know it. So, and in order to find the last white space character, we iterate from the end of the segment, which was start plus threshold, and this threshold is the 80 columns defined above. We iterate until we get to 0. We get to the beginning of the segment, and we iterate back. So we're using I minus minus. If the character at index I is a space or a tab, we can define that the last space, the last white space character is at index I, and that the next time we run this, we should start from the next character. Right. Yes, because this at index I, we are going to have a new line, a white space character, and when breaking a line, we can ignore the white space character. And we needed this next start because the program behaves differently if we are breaking mid-word or if we are breaking after a white space character. So if we found a space, we break, and if we never broke and the last space is not found, then we break mid-word using at start plus threshold, which will be the beginning of a line plus 80, and the next time we start from start plus threshold. So we could also write it like this, I think. I guess. Then now that we know from what index we want to start printing and from at what index we want to finish, we start printing out characters in the line to the standard output, and then afterwards we put a new line, and then we set the we basically ignore the part of the line until the basically we slice the line from the we slice it so that it starts at next start. And then at the end, we free the buffer that getline allocated for the line. Great. So this works. And I remember it was pretty difficult when I tried it last night, but maybe I was just tired. And with this done, we can go on to exercise 123, which is to write a program that removes all comments from a C program. Don't forget to handle quoted strings and character constants properly. C comments do not nest. All right. Quoted strings and character constants properly. Yes, but character constants would not influence our it would not influence our program, right? So anyway, okay, this is going to be, I think this may be more difficult than I have thought. Uncomment.c includes standard IO, and then we are going to also return 0 here. Int I C. Do I need an I? Maybe. And C for the last character, while C is get char, is not end of file. We'll start just printing unmodified output, and then at the end we return 0. Make uncomment, and we just feed it its own source code. Okay, and from C source code. So this is here we're going to use a C++ style comment. The only meaningful text in this line. This is a C++ style comment after code in line, and then we also okay, now we don't really have any place to, okay. I'm going to also add some multi-line comments in here. Iterate over each character in the source code. Okay. So yeah, so we will have to know if we are inside a quoted string, right? So okay, yeah, we could define an like in the word counting algorithm, we defined I think we defined some constants for being inside or outside the as a word, so we could do something like in, out. This is an enum, in and out state, right? And state S. So S is out, and if if C equals a double quote, and then we basically want to consume string literal. Okay, yep. Void consume. This is kind of like parsing, so maybe it makes just more sense. Maybe it just makes more sense to implement everything in like macros. So void consume string literal. So that we know, but in this function we're only dealing with a string literal. So yep, so yeah, so let's see. So in here we are also going to be iterating over get char. It's not end of file. Right, and if C is a backslash, then we probably want to consume an escape sequence. No, actually, right. If C equals get char is yeah, so if we encounter if we encounter yeah, so if we encounter a backslash, then we see if the next character is a double quote, and if it is, we continue the string. So quote char C continue, right? So if C equals double quote break, okay, let's see. If C equals and Oh, okay, yeah, this put char like this, and consume char literal. Continue. Right. Void consume char literal. So void int c while c equals get char. No, it's not end of file. I put char c, right? And so in here, if c is a backslash, and if c the next character is a the single quote, then we continue parsing, right? And if c equals the single quote, no, this is not like this. Oh yeah, sorry. This is a if we encounter a backslash and a right. Let's see if this works for now. Yeah, so right now it still works. And great, so we now basically have a way to do this. Okay, so since I don't think we're using this right now, and we can say if c equals slash, and if c equals get char is also a slash, consume cpp style comment. Continue, and if not, then we print put char. So okay, so if we see a slash, and if the next character is also a slash, then we do not output anything, and technically we should output a single space, because I think this is what the C compiler does. It replaces every comment in its whole with a single space. So I think this is what we're going to do at the end of the consume cpp style comment thing. But anyway, while we are checking for a comment, we do not do anything, right? So void consume cpp style comment, and here void in C while C equals get char is not end of file, and if C is a new line, we break, and in here we put char a single space. Okay, let's see. So wait, what? Put char. No, we can say printf space new line like this. So okay, it seems that we are correctly wait, but what do I have here? What does it say? So I comment okay, so for some reason if it encounters a beginning of a C style comment, we end up with two asterisks. So maybe we are not breaking somewhere. No, you have to continue here. Okay. Right. So we are currently correctly removing C++ style comments, the easier type, and let's say if C equals get if C equals asterisk, C is currently at the next character from slash because we read it in line in the previous if statement, right? So if C is an asterisk, consume C style comment and continue, right? Void consume C style comment in C while C equals get char is not end of file, and then if C is an asterisk, and C is an asterisk, and C equals get char equals slash break printf, and just put a single space. Okay. Okay, so now we are also replacing C-style comments with a single space, and just to make sure, let's see. This is just for testing. Let's see if we include a double slash in here, and if we include a comment inside of here, this should not be replaced. Yeah, and this doesn't get replaced because we are inside a string literal, and apparently it seems that the program recognizes that and replaces it correctly. Okay, now this was very nice. It's nice that this was so easy, and you may be wondering why why we are using such a multitude of functions. And well, this is basically like a parser or a tokenizer, and it's kind of like what we are going to do in the next exercise, which I'm not even going to start today because it's I'm not going to start it because this is much too complicated for it. And since we still have a few minutes left, I could probably go over the code, or I could do a 1000 subscriber special and show you something that I found. Command C, we copy this to working DOS. Okay, and we open DOS box. This may completely break my resolution, so if something looks like crap, it's because of this reason. And I switch to C mode, and oh, sorry, this is not supported. Oh crap. Yeah, sorry. I try to do it full screen, but it doesn't work with my capture card. So I'll just have to try and show it to you on this tiny little screen. Oh well. So basically what I wanted to show you is I have this beautiful TC C TC bin and tc. And open and comment, and I can close this one. Wait, can I close this one? Okay, and window zoom. Okay, so this is Turbo C++. This is the exact same terminal, the exact same IDE I used when I was first learning C back in 2003. And it turns out that most code that we write in this book will still work perfectly fine with an IDE which was developed in 1992. And can we run it? Okay, I'm going to close it. So there. So now we can run this and comment. Yeah. Okay. And comment, we run it with its source code. So wait, do I have something like more? Do we have less? Okay, well, I guess we don't. But maybe we can output it to stripped.c, and then we can open the resulting source code in okay, yeah, so this is the stripped code, and as we can see, the code also worked. I mean, if you can see it, because the screen is, I know the screen is tiny, but I haven't figured out how to scale it without breaking the screen resolution. So this worked, and it's actually pretty amazing that a compiler that was released in 1992 still that the language we are writing is still supported in its entirety by a compiler released in 1992. And I guess I will just call it an episode. And yesterday we passed 1,000 subscribers, and I would like to extend my gratitude to everybody who contributed to that number, and thank you for watching my boring content. If you have enjoyed this episode, please like and subscribe, and if you did not enjoy this content, you can also like and subscribe, because I don't care. And I will see you tomorrow.